Welcome back everybody. We are in Unit 5 exercise 5.2 class 9 English medium introduction part, finding the distance between 2 points. So the points lie on the axis. As you can see, there are 4 possible ways the point can lie on the axis. Those are positive x-axis, negative x-axis, positive y-axis, negative y-axis. There are 4 ways if the point is lying on the axis. So we'll see one by one. As you can see in this, the point is on x-axis. If you mark the number, you know this is 0. This is positive y, this is negative y, this is negative x. So let us assume the point is on x-axis, positive part. So as it is on positive part of x-axis, we can write as 1, 2, 3, 4, 5. Now we are finding the distance between 2 and 5. So we mark the point as 2, 0, 5, 0, and we find x2 minus x1, which becomes 5 minus 2. 3 units. Next, we come to negative part of x-axis. Again, but here we write modulus because distance is never negative. So we write modulus here and we find in such a way that minus 5 and 2. So again we know this is x1 y1, this is x2 y2. So distance will be x2 minus x1 because the point is on x-axis. So this is minus 2 minus of minus 5. So minus 2 will be as it is, minus of minus 5 will be plus 5, so it becomes 3, hence the distance is 3 units. This is simple way of finding it, as it is given in the textbook. Okay. Now, after finding the points on the x-axis, now we are going to find the point distance, that is distance between 2 points, on y-axis. If the points on y-axis, so this is positive y, so I am writing 1, 2, 3, 4, 5. So this can be written as 0, 1, 0, 5, x1, y1, x2, y2. Hence the point distance can be written as y2 minus y1, that is 5 minus 1, that is 4 units. If it is in negative part of y-axis, it will be minus 1, minus 2, minus 3, minus 4, minus 5. Let us assume take 2 points, 0, minus 1 and 0, minus 5. So the distance will be y2 minus y1 because the point is on the y-axis. So 5 minus 1 minus 5 plus 1 becomes minus 4. Because it is modulus, we write as 4 units. Okay. So this is very simple way of finding the distance. But regardless of all this, if the points lie on the plane, that is center of the axis, somewhere around the Cartesian plane, together it is called as Cartesian plane. So as you can see, this is distance between 2 points on the plane. You can see both the points are on the plane, x1, y1, x2, y2. The points are 2, 2 and 4, 5. This is what we are going to study. If the point lies on the plane, this 2, 2 and 4, 5. So because they are not an axis, so we have different approach to find it. Just because we use a formula called now, by using this formula, x2 minus x1 the whole square plus y2 minus y1 the whole square, we find this distance. That is 4 minus 2 the whole square, 5 minus 2 the whole square, 4 minus 2 is 2 the whole square, 5 minus 2 is 3 the whole square. So 2 square is 4 and 3 square is 9, so it becomes root 13. So this distance is root 13. So we have problem regarding these kind of distance So we'll follow this. This is the introduction part. So we have some formula to see in this. Now we see the formula for distance between 2 points, that is d is equals to x2 minus x1 the whole square plus y2 minus y1 the whole square. So now we see the conditions regarding this particular exercise, that is 5.2 exercise 5.2. If you go through this, that is enough. The points to be collinear or the points on the straight line. As you can see, there are 3 points A, B, C, they lie on straight line. So there can be any possible case. So this R or. So AB plus BC is equals to CA, BC plus AC is equals to AB, or AC plus AB is equals to BC. So there can be possible 3 cases. Okay. Next. Our next case is isosceles triangle. So as you know about isosceles triangle, if this is a triangle ABC, either of any 2 sides will be equal. AB equal to BC, or BC is equal to CA, or AB is equal to CA. That we will see in the question. Right? Then comes equilateral triangle. As you know, equilateral triangle, all the sides will be equal. So AB is equal to BC, BC is equal to CA. Next, parallelogram. As in parallelogram, opposite sides are equal. So the vertices will be given to you in order itself. So we have AB is equal to CD, and this is not or, this is and. But both the conditions should be followed. So AB is equal to CD and AD is equal to BC. So finding the distance will be 4 times in this case. Next, we are coming to rhombus. Next, our case is rhombus. As you might have seen, come across Barfi. So that kind of shape is called as rhombus. In this, all the sides should be equal. Next, we are coming to right angle triangle. In right angle triangle, there can be 3 possible cases. Those are AB square plus BC square is equals to AC square, AC square plus AB square is equals to BC square, AC square plus BC square is equals to AB square. So any possible case according to the question is possible. It is need not that angle B will be always 90. It can be A, it can be C. So according to that, we write the formula. Hence, therefore, remember all this formula, and we will go into the exercise now. Thank you. Please like and subscribe the video.